Okay, so today we are going to talk about polynomial operations. So that would mean add, subtract, multiply, and divide will be a different video. So just some quick reminders from Algebra 1 before we get started about like and unlike terms. So you are allowed to add and subtract like terms, and when you do, you would be adding or subtracting their coefficients. So 2x and 3x are considered like terms because both have a single x. 2 plus 3 gets us the 5x. You can't combine unlike terms with adding or subtracting. So if I have a 2x and a 3x squared, those would be considered unlike terms. The first one has an x only, and the next one has an x squared. Those don't match, so those are unlike terms. If you try to add those, you just get the same result. I'm not allowed to combine those in any way. We are, however, allowed to multiply unlike terms. So I could multiply 2x times 3x squared. In order to do that, we would multiply the coefficients. 2 times 3 is 6. And we would multiply the variables. X times x squared becomes x to the third. We have a hidden exponent of a 1 on this x, and this exponent of a 2. So if I add the 1 and the 2 together, I get the exponent of 3. So it's a good idea to just remind yourself of these rules before we go to adding and subtracting polynomials and multiplying. Okay, let's start with adding and subtracting. So we will do a sum and a difference problem. Thank you to Delta Math for the problems. So the first one asks us to find the sum of two expressions. So first of all, just a reminder that the word sum means add. So we are going to take both of those expressions and add them together. I like to put expressions in parentheses. It doesn't matter so much when you're adding, but it does when you're subtracting. So I think it's helpful to get in the habit of doing that. Once I've written these out, I'm going to look for like terms. So it looks to me like we have 2x squared terms, but just one x term and 2 constant terms that we are able to add together. So if we add the x squared terms, we should get a negative 17x squared. The square, the 3x, will remain. And then the constant terms added to 0, positive 3, and then minus 3 goes to 0, so that part is gone. Okay, let's do a subtraction problem. So first of all, we need to distribute our hidden negative 1 that is in front of these parentheses. So negative 1 gets distributed to this term and that one. When we do that, that would actually flip our 6x to a positive. A negative 1 times a negative 6 is a positive 6. Negative 1 times 4 is a negative 4. The terms from the original parentheses, from those first parentheses, will remain. Now again, I'm just going to identify any like terms. The x squared does not have any like terms, but the linear terms do. The 9x and the 6x in the boxes can be combined to 15x. And the minus 4, the constant term, does not have a like term, so that will remain. Okay, let's talk about multiplying. So first of all, you might see a problem that looks like this. Just remember to pay attention to what sign is between the parentheses. If there is no sign in between the parentheses, it is implied to be multiplication. Pay attention though. In our previous example, we had a subtraction between them, so therefore we were subtracting. Here we had an addition between them, so we were adding. Here I have no symbol between them, so we are going to be multiplying. So normally when you multiply expressions like this, you distribute. Some may have learned FOIL. So that means I have to take every single term and distribute to the 2 terms in the second set of parentheses. That is a lot of distributing to do. I have to distribute all 4 terms in the first set of parentheses to both terms in the second set. That's a lot of distributing. Now, I am not here to tell you that that is a bad method to distribute. It just can be a little unorganized and possibly confusing if you have a lot of terms to distribute like we do here. So my suggestion is a way to organize yourself so that you make sure that you're not missing any terms that you need to multiply. So my suggestion would be to set up a box. A lot of you guys have multiplied with boxes before anyways. I am going to make the sides of the box match the number of terms I have for each set of parentheses. There are 4 terms in my first set of parentheses, so I have 4 spots for this side of the box. The second set of parentheses has 2 terms. It is a binomial, so I'm going to have 2 spots. And I'm going to place each term in its own spot along the edge of the box. From here, we are going to multiply each individual box inside. So for example, if I want to figure out what goes here, I'm going to multiply 2x times negative x to the third. So remember, when you multiply unlike terms, or you multiply any terms, multiply the coefficients. -1 times 2 is -2. And then add the exponents of your variable as long as it's the same variable. So 3 and a 1 gets us an exponent of 4. -1 times negative x to the third is positive x to the third. In this box down here, we've got to multiply -6 times 2 is -12. X squared times another x would be x to the third. Multiplying -1 times -6x squared is a positive 6x squared, and I can go down the line. 2x times 2x is 4x squared. Then I get a -2x. And then I'm going to do -3 times 2x, which is -6x, and I finally get a positive 3. So from here, look in your rectangle, in your box, and see if there are any like terms. I see 2 terms that are cubed, 2 terms that are squared, and 2 linear terms. We are able to combine those terms when we go to add everything up inside the rectangle. The -2x to the fourth will stay. That doesn't have a like term. But the -12x cubed and this 1x cubed will combine to -11x cubed. The 4 and the 6 add to the 10x squared. The -6 and the -2x's add to the -8x, and the 3 stands alone. If we want to practice some of our terminology that we've learned before, this is called a quartic polynomial. It's quartic because the highest exponent is a 4. This is degree 4, which we call quartic. It's a polynomial because it has 4 or more terms. This one has 5 terms. 1, 2, 3, 4, 5. The leading term is this -2x to the fourth. The leading coefficient is -2. And the constant term is 3. Okay, let's try some. So here is a problem. Pay attention to the symbol in the middle. This is a subtraction problem. Take a second, subtract these polynomials, combine your like terms. When you are done, unpause the video and listen to the answer. So please pause the video and complete this problem. Okay, so hopefully you are back with a completed problem. The very first thing we need to make sure that we do is distribute this hidden -1 to all 3 terms. That will change the sign of all 3 terms to a positive and then a negative and then a positive. From here, combine your like terms. There are 2 squared terms. Those combine to 11x squared. There are 2 linear terms. Those combine to a 4x. And there are 2 constant terms that combine to -6. That is a quadratic, a degree 2 polynomial. Sorry, not polynomial. We could call it a trinomial if we wanted to be more specific with 1, 2, 3 terms. Oops, there's the answer. All right, so this is a little bit of a giveaway, but here's the final answer that you should be getting. So if you would take a second and pause the video and write out your multiplication, and you can verify that you get the answer that is below. When you are done, you can unpause the video and take a look at your work to confirm. Okay, so hopefully you have completed your work, and if your answer doesn't match the one that's given, let's take a look at our work and see maybe what went wrong. So I've created a 3x3 box, and we are going to multiply each individual box in here. So as we're going through and we're multiplying, some things to check would be that your exponent on the variable is correct. That is often a common mistake. You can check that you've multiplied your coefficients correctly. That is another common mistake. If all of your entries in your box match what is on the screen and you don't have the answer that we have, check your like terms. So I've combined the cubes, the squares, and the linear terms. Finally, if you wanted to, you could name this. This is a quartic. This is a degree 4 polynomial because I have 1, 2, 3, 4, 5 terms. So once we hit 4 or more terms, we will just call this a polynomial. So this is a quartic polynomial. Okay, thanks for watching today.